Palo Alto firewalls, they are often deployed at the perimeter of the network. This essentially means that we install the firewall between the LAN and the WAN side. Just like you see in this topology, we have this firewall, and we're going to consider this side as the LAN side, where we have the interface 1/1, and on this side we're going to call this WAN side. So this normally connects to the internet, where we have the interface 1/3. And in terms of routing, what we do normally, we configure a state default route. And why did I do that? So we're going to configure a state default route, right, on the firewall, and we're going to set the ISP router as the next hop. So for any known or unknown destination, the firewall is going to send the traffic to the ISP router, and it works. Typical simple deployment, it works. But there are scenarios where we might want to choose different destinations with different next hops. And although we can still use static routes or multiple static routes, the better way to do it and to scale is to use dynamic routing protocol. So in this video, I'm going to show you how to deploy dynamic routing protocol. More precisely, we're going to deploy OSPF and BGP in this deployment. So in this deployment, we're going to configure OSPF on this interface. Okay, so the interface 1/1, that's going to be enabled for this subnet 10.1.0.0, okay, which means we're going to change this switch to become a layer 3 switch, so that we can have a subnet on this interface, the 00 interface, and another subnet, the 10.1.1.0, on this interface. And this Linux PC has the IP address 10.1.1.1.5, and then it has the switch as a default gateway with the IP address 10.1.1.1.3, and probably we have to configure that. Okay, so we're going to enable OSPF on this direction, and we're going to enable BGP on this direction. Okay, so the firewall is going to use the AS or ASN number, autonomous system number 64513, and we're going to establish a peering with this ISP router that is going to be in AS 64512. Now we're not going to enable NAT between on the firewall, so that we can advertise all the networks to the ISP router and vice versa. So by the end of this video, this PC, it should be able to reach this router on the subnet 1.168.1.0. Okay, so I have cleared or reset the firewall. So we're going to start all the configuration from scratch so that you can follow along as well. So the first thing we're going to do is to assign to take care of the network part. So zones and interface. So first thing, we're going to create 2 zones. Okay, so we go to add, and we're going to create the inside zone. That's going to be layer 3, and we're going to save this, and we're going to create another one, and that's going to be the outside zone, and the type is going to be layer 3 as well. So we're going to save this. Now let's go to interfaces, and interface 1/1, that's going to be the inside interface. So we're going to change the type to be layer 3, and the virtual router, we're just going to choose the default security zone. We're going to assign this to the inside security zone. Now IPv4, we're going to add new IP, and that's going to be 10.1.0.1/24. okay, and we're going to save this. Now we're going to assign the IP address on the 1/3. The interface type is going to be layer 3. Virtual router is going to be default, and security zone is going to be the outside. As for IP, we're going to assign the IP address 1.168.1.1/24. Okay, so this is done. Now by default, the firewall won't reply to ICMP packets or ping. So in case we want to test for troubleshooting or any reason, so we're going to assign a management profile or associate a management profile with these interfaces. So we just go to network profiles, interface management, and we're going to add management profile and just select ping, confirm this. And now let's associate this management profile with both interfaces. So in case we have to troubleshoot reachability, we can do that. So let's go to advanced, and here management profile, we're going to reference the management profile we just created. Going to save this. Let's do the same for 1/3. Just go to advanced, select here management profile and save. Okay, before starting configuring the routing protocols, let's just make sure that we can test the reachability from the firewall to the switch and to the router. So we're going to commit this change. Okay, and meanwhile I'm going to the ISP router and validate if I already have BGP. No, I don't. Okay, that's great. So here on the switch, I have to validate if I have OSPF configure. No, I don't. Okay, so meanwhile, let's just validate. Okay, so it's still running. So let's change a couple of things here on the switch, and I believe that's interface E00. So let's just double check that. That's the interface that connects to the firewall. So we want to disable this port from being a layer 2. I'm going to make it a layer 3. Okay, and we're going to assign the IP address 10.1.0.3 and assign the mask. Done. And now the interface 02, no switch port as well, and assign the IP address 10.1.1.1.3. Okay, now I'm going to enable OSPF on these interfaces. So IP OSPF area 1, and going to assign the router ID can be 10.1.0.3. Okay, to show IP OSPF interface brief. So this is done, OSPF enabled, and from the switch I should be able to reach 10.1.1.1.5. That's the Linux 5 PC, and it's successful. Okay, so the firewall should be ready. Okay, which means that probably we should be able to ping the firewall from the switch 10.0.1.1. Okay, and it's successful. That's great. So we don't want to start configuring advanced settings before validating that we have reachability from just the IP address. So we're going to test also from the ISP router 168.1.1. Okay, and it's working. Okay, so from a reachability perspective, we are sure that the firewall and the switch, the firewall and the router, they are able to reach each other. Okay, that's awesome. So now let's go to the first step. And the first step, we want to enable OSPF on this direction. Okay, so let's go to the firewall, network, virtual router, default, and let's go to OSPF, and we're going to enable this, and we have to type the router ID. The router ID is going to be used to identify the firewall in the OSPF process. So that's going to be 10.1.0.1, can be any number. So 10.1.0.1, and then we have to say, okay, what's the area? And in this case, we have to use, that's the way we represent area. So if you are a network engineer who has been working with Cisco networking, so things are a bit different here, but although we can also configure area using this type of representation. Okay, but here on the switch, I did a different one. So let me show you. I'm using this. We can configure this way on Cisco devices, but on Palo Alto, that's the way we do it. Okay, so this is the area, so it's area 0. Now on which interface we're going to enable this? So we're going to add, and let's select the interface 1/1. Okay, we're not going to change anything here. Okay, just enable on this interface. Okay, so just make sure that everything is okay. Okay, and let's commit this. Now we could just configure OSPF and BGP at the same time, but I want to show you step by step so that you understand, and in case something doesn't work, you're able to identify, okay, which steps or which configurations I have to change to solve the problem. Okay, the configuration was committed successfully. We can close this and we can tell that it was configured and it's working just by looking here. So we have one area, one subnet, and we have one neighbor count. And if we go here to more runtime stats, there are a couple of things that we can use, that we can see to validate that. We should see that the switch 3 is going to advertise the subnet 10110 to the firewall, and you should see here 10110, okay, being advertised by the switch, and you can see that it's active. This is OSPF and it is intra-area OSPF, and it's being advertised via this interface, okay. And we have one neighbor there. So if we go to OSPF tab, we can see that we have one neighbor, and that's switch 3, okay. So this means that from the Linux PC, we should be able to reach the firewall, okay, because the switch knows how to reach on this subnet. Okay, so okay, this is done. Next step will be, okay, to establish BGP adjacency between the firewall and the ISP router. So let's go to the firewall, going to close these. Let's go to virtual routers, BGP, and we're going to enable BGP, going to set the router ID to be the same, 101. The AS number, as you can see here in the topology, that's 64513. So 64513. And we want to, we're going to install routes, and let's go to peer group, add peer. And here we're going to create BGP peers. Now let's call these eBGP peers, just to represent all external BGP peers. It means that peers that are not in the same ASS, don't have the same AS number. So type is eBGP, and we're going to add one eBGP, and name I'm going to set to router ISP, because we can have multiple eBGP peers. Peer AS is going to be 64512, and the interface, that's going to be 1/3. Local address is going to be 1.168.1, and the peer address is going to be 1.168.1.7. Okay, and just make sure that everything is okay. Yes. Okay, just validate. Okay, and we can save these and commit this change as well. Now, meanwhile, let's go to the ISP router and configure BGP. So BGP 64512, BGP router ID, in this case 168.1.7. The neighbor is 168.1. Remote AS is 64513. And yeah, let's just advertise. Let's look at the to show IP route connected. So I'm going to advertise the subnet 1.168.1.0 so that the network 10.1.1 is able to is going to be aware of 1.168.1.0. Okay, let's go back to the ISP router. So 1.168.1.0, and we can see that the BGP peering is up with the firewall. Okay, so if I run the command do show BGP summary, let me just extend this a little bit, and it looks like it is behind. Okay, so we should see we have one neighbor 168.1.1, and we should see state prefix to 0. Yes. Okay, and I'm going to advertise the 1.168.1.0. Okay, we have BGP enabled. Let's close this, and we can see here enabled peer count, peer group count, local prefix. If we refresh this, we should see one local prefix count. If we go to more runtime stats, and we're not going to see much here because of the 16810. This is a directly connected interface on the firewall. But if you go to the BGP tab, local read, we should see that we have received the prefix being advertised by the ISP router. Okay, that's great. So we can see also check some information about the peering. That's great. Now, the firewall, what we have so far is that the firewall knows how to reach the 10110 and 10100 because it is directly connected, and also the 16810. Now we have to advertise these networks to this side and advertise these networks to this side. So we have to redistribute those networks, those subnets between these two routing protocols. How do we do that? Okay, so first let's start with the OSPF into BGP. So we're going to close this. Let's go to virtual router again. And first thing we have to do is to create a redistribution profile. So let's name these as OSPF to BGP. Priority, let's set to 1. We're going to select OSPF as the source type and make sure to change these from non-redis to redis. Okay, this is a very important step, and we're going to save this. Okay, now let's go to BGP and redistribute rules. We're going to add the redistribution profile just created, OSPF to BGP. That's all we have to do. We're going to save this, confirm this, and commit. Okay, now we should see that the firewall is going to inject those subnets that are in OSPF into BGP. Now to see this happening, can enable the command do debug IP routing, and we should see that those subnets are going to be injected on into BGP. We're going to see these on the ISP router. Okay, and the configuration was committed successfully, and we can see that BGP updated its tables, so it added the subnet 10100 and the 10110, and we can double check that. So if we look at the BGP table, you can see those two prefixes or subnets being advertised by the firewall. Okay, so now let's inject the BGP prefix, in this case the 16810, into OSPF. Okay, so let's go to firewall, and we're going to create another redistribution profile. So let's go to redistribution profile, add, and now we're going to name this as BGP to OSPF, and we want to redistribute, set the priority, going to select the source to BGP, going to save these, and now let's go to OSPF, export rules, add. We're going to select the redistribution profile BGP to OSPF. Okay, we're going to save these, and we're going to commit. Okay, and the configuration was committed successfully. So let's go to the switch and let's confirm the routing table. So we can see that the subnet 16810 is being advertised, okay, from the firewall, and looks like it's working. So we have configured OSPF and BGP, and we also enable redistribution between these two routing protocols. Now, does it mean that this PC should be able to reach the firewall, or I mean the ISP router? Let's check. I'm going to log in. And let's try to ping first 168. First, can I reach 10101? Yes, I can. What about 16817? And I can't. Well, I can't because the firewall is a firewall, and by default, all the traffic is going to be denied unless we explicitly allow the traffic we want to be permitted on the firewall. So let's change this. So let's go to the firewall policies, and let's add a policy. So I'm going to keep this simple, just inside to outside. The source is going to come from the inside zone. The source address we can specify, just leave it as it is, and the destination is going to be the outside. And just going to commit this. So we're going to allow everything coming from the inside to the outside. So just going to commit and wait for the results. Okay, let's check again on the Linux PC, or Linux PC on Linux. Linux PC. So we can see that now it's working, which means that we are able to reach the ISP router from the Linux PC. And that's how we deploy OSPF and BGP on the Palo Alto Firewall. If you took value from this video, don't forget to subscribe, hit the like button, and I'll see you on the next one.